Assalamualaikum and hi students. Okay, so dalam video kali ni saya nak buat video sebab saya rasa saya just nak discuss jawapan sahaja. So it's easier if you just watch this video and then you can know the answers from this video lah. So sekarang I'm discussing the answers for tutorial week 5 first hour non-face-to-face for chapter 2 atomic structure. Make sure you watch this video in order for you to get the answer. Okay. The first question asks you to describe Bohr's atomic model of hydrogen atom. Okay, so for this atomic model of hydrogen atom, we've discussed this during our lecture last Thursday. So what you have to do is you have to include all four postulates inside your answer. So remember, Niels Bohr came out with 4 postulates explaining the atomic model of a hydrogen atom. So you have to include all 4 postulates in your answer. So the first postulate says that the electron moves around the nucleus in a fixed circular orbit. Okay? And the second postulate is that electron at certain energy level has certain amount of energy or the energy is quantized. So macam awak tahu, orbit, dekat setiap orbit tu they have their own energy level. So apa-apa je elektron yang duduk dekat that orbit will have their own energy, or we call it as energy is quantized. And the third postulate is that an electron moves in an allowed energy state will not absorb or radiate energy. What does it mean by allowed energy state? Maksudnya elektron tu dia duduk in its own orbit. It doesn't move to other orbits. So if an electron stays in its own orbit, that means no change in energy will happen. However, moving on to the fourth postulate, energy is emitted or absorbed by an electron as it changes from one allowed energy state to another. That means if an electron transitions from one energy state to another, contohnya dia duduk dekat orbit nombor 3 but then it moves to orbit nombor 4, so there will be change in energy there. So you have to include all these 4 postulates inside your answer. Now, question number 3 asks you to calculate the energy of an electron at n equals to 1. So remember, in our lecture, we have discovered many formulas for you to calculate energy value of an electron. And this is one of them. When are you going to use this formula? Is when you are going to calculate the energy value of an electron when it stays in its own orbit, when it doesn't move to any other orbits. So you just have to use this formula. Now, since n equals to 1, so we are calculating the value of energy when electron is at n equals to 1. So E1 equals negative, remember RH is the value for Rydberg constant. So this is the constant, Rydberg constant, right? So you just have to plug in the value, which is 2.18 times 10 to the power of negative 18 joule, and then inside your bracket you put 1 over n is equals to 1 now, so 1 over 1 squared. So you should get just the same value, negative 2.18 times 10 to the power of negative 18 joule. That will be your answer, simple. And then the next question asks you to calculate the energy of electron at n equals to 5. Again, this is very simple using the same formula. You just have to plug in the value. So E5 equals negative 2.18 times 10 to the power of negative 18 joule in bracket 1 over 5 squared. Make sure you type in the right numbers on your calculator in order for you to get the right answer. So your answer should be negative 8.72 times 10 to the power of negative 20 joule. Reminder for you to always use joule as your unit and never leave out any unit in any of your calculation. The next question asks you to calculate the energy of electron at n equals infinity. Now this is quite tricky because infinity, we don't know what is the value of infinity. What we know is as the number gets bigger, it is approaching infinity. Okay, and in maths, what you have learned in maths, I'm pretty sure you've learned this in maths. If you divide 1 over 10, let's say, so you'll get the answer to be 0.1. Okay, let's say you divide 1 over a bigger value, 1 over 1000, so you will get the value to be 0.001. And as you divide 1 over a bigger value, let's say 1 million, so you'll get even more. I'm not quite sure if this is the right number of 0, but yeah, as you can see, as you divide 1 by a bigger number, the value of the answer that you get is approaching 0. See, so what we can conclude from that is that when you divide 1 over infinity, so you can get the answer to be 0. Okay, so this concept is what we're going to apply in answering this question. Since the question asks you to calculate the value of energy at infinity, so using the same formula, using the same Rydberg constant, it will never change, right? So 1 over infinity squared. So we can conclude that this value here is equals to 0 because we divide 1 over infinity, right? So when we have concluded that, so any value, when we multiply any value with 0, so you can get the answer to be 0 joule. Okay. This question asks you why the value of energy of electron at every energy level is negative. Every energy level. This has something to do with the value of energy at infinity. The previous question asked you to calculate the energy of an electron at infinity, and you got the answer to be 0 joule. This means that if I draw for you the energy level diagram, they say I draw this for you. Okay, so at n equals 1, n equals 2, n equals 3, n equals 4, n equals 5, up until n equals infinity. At infinity, the value of energy is equals to 0 joule. That means the value of energy at lower energy level compared to infinity will be En equals negative value of energy. Okay, this is because as the electron move closer to the nucleus, the attraction between the nucleus and the electron causing the value of energy to be negative because there is an attraction between electron and also the nucleus. So this is your answer. When electron is at infinite distance from nucleus, its energy is 0. So when it is brought near to the nucleus, energy becomes less than 0. This is because the force of attraction between the nucleus and the electron. So you have to write down the answer. Write down this answer in your answer lah. Okay. Moving on to the next question. It asks you to calculate the difference in energy between n equals 1 and n equals 2, where n initial equals to 2 and n final equals to 1. So this is where you have to use another formula to calculate the difference in energy between the two energy levels. So what happens here is there is an electron, and this electron moves from one energy level to another energy level. So let's say this is your nucleus. Then, okay, so here is n equals 1 and here is n equals 2. Since the question asks you to calculate the energy difference when n initial equals to 2, that means your electron moves from n equals to 2 and it goes down to n equals to 1. So this is what happens. So that's why you have to calculate the energy difference. And here is the formula that we have covered in order for you to calculate the difference in energy between the two energy levels. Remember, the electron is only one. There is only one electron, but there are two energy levels. That means that the electron moves from one energy level to another energy level. So using this formula, right, so delta E equals, remember, value of RH, Rydberg constant, is 2.18 times 10 to the power of negative 18 joule. Never leave out the unit, okay? In bracket 1 over n initial, it it's stated here that the n initial is n equals to 2. That means the electron comes from energy level number 2. Okay, so 2 squared minus 1 over final is 1 squared. So make sure you plug in the right value into your formula. So you should get the answer negative 1.635 times 10 to the power of negative 18 joule. So for the next question, the question asks you to calculate the difference in energy between n equals to 2 and n equals to 3. And it is stated here that n initial is 3, whereas n final is 2. That means your electron moves from energy level 3 to energy level 2. Right? So using just the same formula, you just have to substitute the value into the formula. Right? So Rydberg constant 2.18 times 10 to the negative 18 joule. 1 over initial is 3 squared minus 1 over 2 squared. So your answer should be negative 3.028 times 10 to the power of negative 19 joule. And then in this question, the electron moves from n equals to 4 going down to n equals to 3. Okay, again, just plug in the value. 2.18 times 10 to the power of negative 18 joule in bracket 1 over 4 squared minus 1 over 3 squared. So your answer should be negative 1.06 times 10 to the power of negative 19 joule. Never leave out the unit, remember. And then the last question asks you to deduce the trend of energy differences above. So from the energy differences that we have calculated before, so when you calculate the energy difference between N1 and also N2, let's just put it as delta E1, you get the answer to be negative 1.635 times 10 to the power of negative 18 joule, whereas the second energy difference is negative 3.028 times 10 to the power of negative 19 joule. And then the last one is negative 1.06 times 10 to the power of negative 19 joule. Okay, as you can see here, first you have to look at the number of power. So it started with negative 18. That means we have 18 0 in the value, 18 0 number in the value. And then it goes down to negative 19, negative 19. That means you have 19 0. So this means that the two later values here, okay, the two later values here approaches 0. These two values approach 0. Okay, and then let's look at the value. Let's look at the numbers. So between these two, wait, before that, so this has the biggest value. Okay, and then the two value at the bottom here, it approaches 0. Okay, since there are, it approaches 0. And then between these two numbers, this number is the smallest value. Nombor yang ni paling kecil. What does that tell you? That means that as the energy level gets higher, as it approaches infinity, okay, as the energy level approaches infinity, the energy difference value approaches to 0. Ingat tak macam soalan yang before ni kita jawab, bila makin besar energy tu, kita bahagikan satu bahagi that level of energy, so energy dia akan mendekati 0. So same goes to this one. Lagi besar energy level dia, lagi tinggi energy level dia, okay, kalau yang macam yang ni energy level antara yang ni antara N3 and also N4. Yang ni antara N2 and also N3. Yang ni antara N1 and also N2. So makin besar number dia, makin kecil dia punya energy difference. Okay, so kalau saya lukis dia punya energy level diagram kan. Okay, so this is the energy level diagram. Right, so this is N equals 1. Okay, this is N equals 2. Okay, besar energy level dia. And then as it approaches, kalau dia makin dia ke atas, makin kecil dia punya energy level. Okay, so bila dia 2 dengan 3, dia kecil sikit. N equals 3. And then bila dia dengan 4, N equals 4. Contoh. Okay, so as you can see here, energy level dekat sini, energy difference dekat sini besar compared to this one and also this one. Okay, so what you can conclude from this is that, wow, the trend shows that the energy difference value approaches to zero. Let me just write that down again. The trend shows that the energy difference values approaches